Hi folks, I'm here in sitcoms.r and you'll want to get this from the class website along with corresponding data set sitcoms.csv. Here we are going to look at differences in perception of American TV audiences to 4 different sitcoms that aired on major network TV. So let's import the data set. I'll use this little button over here from text base, surf over here to the data set folder where I've got this stored, and here it is, sitcoms.csv. And we got to remind R, hey, there actually is a row of names, a header row here, and now it understands, hey, that's the viewer, that's the show, these are the questions. So just for some background here, all of these questions are survey responses to a panel of, I don't know, about 360 individual participants in a television survey, where they basically gathered a whole bunch of people, said, here, we're going to show you the pilots, the first episodes of a bunch of different sitcoms, and then we're going to ask you some questions about them. The Q1 variants here are all about like how the show made you feel. So this show made me feel attentive, this show made me feel excited, this show made me feel happy, etc. Respondents were asked to rate to what extent they agreed or disagreed with that statement on the 1 to 5 scale presented to them, where 1 meant strongly disagree and 5 meant strongly agree. So for example, viewer 97 felt very, very attentive at 2.5 men. Let's come back to the script. So the data set here that we're going to, the variable that we're going to work with here is the funny question. So the variants of the question for Q2 here are all this show, I found this show to be, insert blank adjective here. I found this show to be funny. I found this show to be confusing. I found this show to be predictable. So, you know, for example, let's take viewer 83 on the second line here. This viewer rated a 4 out of 5 on terms of how funny they found The War at Home, which is the show for that particular row. So this model that we're going to be fitting is a dummy variable model. We're going to have Q2 funny as the response, and we're going to regress that on the show variable. And these variables that come out are ultimately going to be dummy variables. So as a quick reminder of how dummy variables work, let me pull open this slide here, which we went over in class. So this is that same data set. You've got the viewer, just a unique numerical code, their rating of a particular show on the funny scale, to what extent they found that show funny, 5 being the most strongly agree category. And then here's the show that they were rating itself. So for example, here's viewer 97. They appear 3 times because they rated 3 shows, 30 Rock, My Name is Earl, and 2.5 Men. And, you know, clearly they didn't find 30 Rock funny, but they found My Name is Earl and 2.5 Men absolutely hilarious. So how do we encode this information, which is like the answer to a multiple choice question, which show are you rating, in dummy variables? Well, here's how we would do it as a reminder. So for example, this viewer's rating of this show corresponded to The War at Home, and so we would give a 1 for this dummy variable here, War Home. That means 0 is you were not rating War at Home, 1 means you were. So we can see these 2 ratings of The War at Home, they both get 1 for that dummy variable. Here are ratings of My Name is Earl right here. They get a 1 for that dummy variable and a 0 for the other 2. Here's a rating of 2.5 Men. It gets a 1 for that dummy variable. And here are some ratings of 30 Rock. You notice there's no dummy variable for 30 Rock. That's because with 4 categories, a 4th dummy variable would actually be redundant. If I tell you there are 4 shows, 30 Rock, War at Home, My Name is Earl, and 2.5 Men, and I give you the dummy variable information that it's none of the other 3. It's not Earl, it's not War at Home, and it's not 2.5 Men, well, you know it's 30 Rock. That's why we only need 3 dummy variables to encode 4 categories. Okay, so with that in mind, let's go back to the R script. This model right here is actually fitting that dummy variable model that we were talking about on the slide there. Let's take a look at the coefficients here. I'm just going to type coef lm sitcoms into the console down here. And now we get 4 numbers here. We get an intercept, and then we get offsets associated with the My Name is Earl dummy variable, the War at Home dummy variable, and the 2.5 Men dummy variable. Let's try to interpret these coefficients side by side with a little dot plot right here. Okay, so let me make this a little bit bigger over here. This plot over here shows the individual ratings of all respondents to all shows, and these orange dots, so there's a little bit of jitter that's been added just to allow you to distinguish the individual points from each other and know, hey, there's like a ton of them up here and only 4 or 5 of them down here. These orange dots are the means, the mean rating for 30 Rock, the mean rating for My Name is Earl, and so on for all of the other shows. Let's try to get side by side. Let me come back and get these coefficients on my screen again. Here they are. let's interpret these numbers side by side with this plot. This intercept, 3.4, that represents the baseline. 30 Rock comes first alphabetically. It's the baseline category. And sure enough, you look at where that orange dot is, hey, it's about 3.4. That's the average audience rating for 30 Rock. All of these other numbers, it doesn't mean that 30 Rock got a 3.4 and My Name is Earl got a 0.5. What it means is that My Name is Earl got a rating 0.53 points higher than 30 Rock did. And so if we add those numbers together, about 3.4 and about 0.54, what do you get? You get something just under 4, and sure enough, there you are. This number, this coefficient on the My Name is Earl dummy variable, which, again, to come back to this coding right here, would be the variable that loads on this column right here in your regression model. That coefficient is estimated to be 0.53. That's the vertical distance between that orange dot and that orange dot right there. And ditto for the other shows. The War at Home, that's a 0.34 difference. 2.5 Men, that's a 0.547 difference or so. So all of these three things are measured as offsets from the baseline of 30 Rock, and that choice of baseline is totally arbitrary here. R chose 30 Rock to be the baseline just because it comes first alphabetically. All right, so we can see those coefficients. The other thing that we want to make here, point that we want to make, isn't just about this baseline offset form. It's also about the inherent uncertainty of generalizing from a sample to a population. This is, after all, a sample of TV viewers. What does it say about what the wider American TV audience might say about these shows? So our solution is going to be to bootstrap the sample. That is, sample with replacement from the original sample, the same size as the original sample, over and over and over again. So each time we call that command right there, we are refitting our original model, like this model down here, to a slightly different data set. It's a different sample with replacement from our original sample, and a shorthand for that is a bootstrap sample. Of course, doing this once or twice or 10 times isn't enough to get a sense of sampling variability. We got to repeat it many thousands of times, and that's what this do 10,000 times is about. That syntax is made available as part of the Mosaic library, so you have to have loaded that to work. Ours is going to take a little bit of time to think about this because, hey, we're refitting a regression model 10,000 times. It's not a mathematically trivial operation. Even a reasonably fast computer takes a while to do it. So let's just hang tight here while we bootstrap. And you notice I'm storing the result of this Monte Carlo simulation in an object called boot sitcoms. This will be my bootstrap sampling distribution for this model fit to the sitcoms data set. And at the end of the day, what we get here are 10,000 different estimates of our coefficients. One estimate for each bootstrap sample. So every row here represents a bootstrap sample, and the columns represent the 4 coefficients or parameters of our model. The baseline, in other words, what do we think the population average response to 30 Rock would be if we could ask everyone? Variability about that number right there. The offset for My Name is Earl, offset for War is Home, offset for 2.5 Men. All right, so let's use this information here and try to say something about what we think the average population level response to 30 Rock would be on the basis of this sample. So we're going to take this column right here, the intercept, remembering that the intercept or baseline in this model corresponds to our baseline category of 30 Rock, and plot all 10,000 of these samples in a histogram. So the interpretation of this number would be, well, we think we're getting an answer about 3.4 for our particular sample. But if we were to take different samples, not just one, but say 10,000 different samples, each of the same size from our original population, this is the distribution of answers that we think we might get. So let's try to eyeball a confidence interval here, a range of plausible answers for the population number in light of our sample estimate. So a 95% confidence interval covers the middle 95% of this distribution. So kind of eyeballing it, maybe about 3.1 down here to about 3.6 up here, kind of gets you from about the 2.5 to the 97.5th percentiles of this histogram. Let's actually, maybe calculate that by hand, right? Well, I'm sorry, not by hand, but we'll get down here in a second to looking at the actual confidence interval calculated by R. So that's our eyeballed confidence interval from this histogram. Let's try one more term. Let's try the My Name is Earl term. So here's our histogram of our bootstrap sampling distribution for the my name is Earl coefficient. Now remember, this coefficient does not represent the average survey response for the show on a 0 to 5 scale. Remember, it's an offset. It is the difference in average responses between My Name is Earl and 30 Rock. And because we're getting primarily positive values here, we think that on average, American TV audiences, whatever is in their head, think that My Name is Earl is a funnier show than 30 Rock. I might personally disagree with that. You might personally think it's the right answer, but hey, all opinions differ, and this number right here is trying to get us an average opinion across the population. And the range of this histogram is telling us our uncertainty associated with that number. Again, eyeballing the confidence interval, maybe from about here, maybe 0.3, say, to about, I don't know, here, 0.8, something like that, maybe 0.15, a little bit lower. I'm not sure. Let's ask R for sure, right? What's the confidence interval associated with all of these model terms? So the intercept, hey, we think it's somewhere between 3.15 and 3.63. That would be the population average response to 30 Rock, if we could ask the question of everybody. Here's the offset for My Name is Earl, somewhere between 1/4 of a point higher than 30 Rock and 0.8 of a point higher than 30 Rock. And if you want to round these, you can get R to round only the numerical columns of this little data frame using this handy little rounding trick right here, the mutate if function. Mutate only the ones that are numeric because R, hey, doesn't know how to round something like the word percentile or the phrase showed 2.5 men. What about R squared for this model? Well, one thing I want you to notice is that it's really, really small, less than 3%. So in terms of substantive conclusions that we could take away from this analysis, number one, I might focus on this right here. Most variation in viewers' rating of the funniness of a sitcom is individual to the viewer rather than systematic to the show itself. And it's like 97% or more of the predicted response here that's down to the individual, just how funny they think the show is. And it's not something systematic to the show itself. Tastes differ, right? So it's a very low R squared model. Very little of the variation in audience response can actually be predicted by the show. Number two, however, is that there do seem to be some differences among the shows that shake out even on average. The difference between average audience response to 30 Rock, which is somewhere between those numbers, is probably, and the difference between that and the audience response to My Name is Earl, that is probably not a small sample difference. Because remember, if it were a small sample difference, in other words, the population had equal opinions of these two shows, that confidence interval would probably contain the number 0. It doesn't. We've kind of ruled out no difference as a plausible value here. Because remember, that dummy variable tells you what the difference is for the wider population. And we don't know what it is, but we think it's somewhere between about 1/4 of a point and 0.8 of a point in light of the sample uncertainty that we're seeing here. Okay, so to review, we've seen a few key skills here. First of all, we've used baseline offset 4. That is a linear model, coming back up here, right here, to express how a numerical variable changes across different groups. And the coefficients of this model give us exactly the answer to that question. We think there's the baseline response for 30 Rock. All of these numbers represent differences between average audience response from the baseline and average audience response for a particular show. Number two, we practiced bootstrapping. We bootstrapped this sampling distribution right here, repeatedly resampling with replacement from the original sample to simulate our sampling process and get a sense of how sampling variability affects our overall uncertainty. And number three, we calculated confidence intervals, first just by kind of eyeballing from a histogram like that, and then using the confident function. And we're very careful to interpret these confidence intervals. Remember, that's not the response to My Name is Earl. It's the difference in response between My Name is Earl and the baseline. So, good example here that kind of combines a lot of skills, bootstrapping and the use of a linear model to get variation in numerical outcome across different groups, in this case, TV shows.